So basically, for this week, I believe you haven't start any theory class with the Tizari, right?
So far, no, sir.
Okay, so because at least the today's class is I believe the first class of this subject in this week. Okay, never mind. For a start, I'm going to give you a brief about this subject in general view before we're going to do some tools or start learning some tools that you are supposed to use in your project. So basically, as an introduction, this subject automotive engineering design is basically being divided into two parts: auto design 1 and auto design 2, where the auto design 1, as you know, is just 2 credit, and auto design 2 is 3 credit. So for the first part is basically we are targeting to introduce to you in the process of engineering design roughly. Okay, the overall subject for this 2 credit subject is for you to learn about engineering processes. And then for the second part for this subject, which is the auto design 2, all of you need to fabricate the design that you made during your AD1, which is in this semester. Okay, so before that, okay, let me show you the overall view about for this subject. Before that, screen. So can somebody please record the video? So somebody please record the video. May I know who's going to record the video? Muaz, agree with Fana? Okay. Mana tahu kan tak setuju kan? Okay. Okay, so Muaz, please record this video. Okay, so basically yeah. So can you see me? Okay, so can you see my screen right now?
Yes, Doctor.
Okay, so basically, for today, I'm trying to give you what the general view for this subject and what you are supposed to do in AD1 and AD2, and also a brief overview of what are you going to learn throughout this semester and also the next semester. So previously we have for you SEMV. Sorry. Okay. 3512 and 4513 to design. Okay, so this subject is all about so auto design 1 in auto design 1. So you're going to take a look up to the your output for auto design is just engineering proposal. And for your auto design 2, the output is going to be up to the fabrication. Okay, this fabrication plus report. Okay, and then hopefully in auto design 2, all of you already in UTM, and can do the fabrication work at the auto lab. Because previously we have for the automotive engineering design, we only have one subject, which is a 3 credit subject, where your seniors they need to propose the engineering design and also do the fabrications. But the project which was involved at that time is just a small scale project, which is involve a subsystem of automotive system, such as the brakes, the steering system, the differential systems. Okay, your seniors need to design, propose and make it as a engineering proposal, and they did it during the first part of the semester, and then during the second part of the semester, all the fabrications take place, and then the fabrication involve both mechanical design and as well as the electronic design. Okay, but for you, you are the first batch, which the auto design being divided into 2 parts. Okay, you are the first one going to start it with, because we want to enhance or focus more on each phase of engineering processes, which is the first one. In general, focusing on the process, which the outcome is the engineering proposal, and then the second one is the involving delivering what you plan. Okay, which is what you already proposed in your proposal. And this is actually the one, this is actually the process typically being applied in the industry. So as an engineer, you're going, before a new project going to take place, usually your boss is going to ask you to make some engineering proposal of a product based on the market input, or based on the survey done by the marketing team, or based on the direct order from the top management to produce something. So it's your job to come with this engineering proposal. Okay, and then this engineering proposal usually it comes out in general definition before you start narrowing it down into the technical definition. Okay, and then once you come out with this engineering proposal, it will go through the management approval. Okay, once it's been approved by top management, and then you're going to start with the fabrications. So same thing for this subject. So you're going to make myself and the Izahari going to put some, going to make as if we're going to request you to make something, and then you're going to propose how to do it. And then once both of us give the approval on your design, and then you're going to continue with the fabrication of this proposal next semester. Okay, any questions so far?
No question, Doctor.
Okay, good.
Doctor, I have a question, sir.
Yeah.
All right. If we were to, okay, I am among the student that is living near the campus but outside the campus. If we were to want to take a look at the prototype at the automotive lab, can we ask for your letter of dia kata macam surat masuk?
Yes.
Surat kebenaran masuk.
Yes, you can. So basically, first, the prototype being kept at the automotive lab. Okay, that was the first one, and then the second one, if you want to come in UTM, so basically you need consent from me, either from me or Dr. Izahari, for meeting. So with that meeting session, and then you only with the missing session that being arranged, then you can come in, because you're going to get the approval from both of us, either one of us. Okay, and then the second one, and then the third one is that you cannot come in the whole class at once. Okay, so depending on the importance of the meeting. So right now it's actually at the beginning of the semester. So yeah, it's not that important for you to take a look at the prototype. So usually you're going to refer to the prototype when it comes to the actual fabrication of your work. Because sometimes you need to refer to the currently available work. But I'm not sure if the most of the prototype is still intact. I think some of it being kept properly and some of it already being disassembled. Because yeah, the most of the parts on the your seniors project, only the best one have been kept, properly kept, while the rest already being in December, so that we can recycle some of the parts, especially the sensors, the boards, the wires. Okay.
Okay, understand.
Okay. Chair, any other question?
Yes, sir.
Okay.
Question. What happen if one of the team member fail auto design one?
And then the whole group going to fail.
Whole group fail.
Yeah. So this is auto design, and then one more thing, you need to remember that this is a teamwork. So if one didn't function, so you need to take over that work. Okay. And if you insist not to take over that work, and then the whole group going to fail. Okay.
So the big group will have a problem lah. One of the
Yep, the whole group going to have problem. So please make sure. I know there's going to be problem maker. Okay, so this problem maker, please bear in mind. So don't cause your friend to be dragged into problems. So just do what you're supposed to do, and then and then hopefully everybody is going to pass the subject, and then continue in the auto design too. Okay, because I know I mean several times, not only every batch, there's always a sleeping partner students, a problematic students. Okay, and then the one that didn't give a good cooperations, and then just appear at the end of the project. Okay, so I don't want that to happen, because usually Dr. Izari and myself, we are also going to monitor this kind of your progress. Okay, we're going to do it on weekly basis, and then for those who are having this kind of problem, especially in subgroup, so you need to inform us as soon as possible. Okay, so that these students, we're not going to fail, but we have something that we can use to teach this kind of student. Okay, we're going to give some lesson. Okay. Okay, any other question?
Yes, doctor.
Yep.
When auto design too, we are going to do the fabrication.
Yeah.
So financially, who will support this?
The student, of course. So that's why the student need to take care of the cost, but that's why you need to make sure that your design is not over designed. So you need to optimize your design, and then also we're not going to usually it will not involve for very expensive part. It's just a cheap one. Usually for sensors, I can show you sensors, cheap one, 5 ringgit, 10 ringgit, 50 ringgit, cheaper than your top up. And then the boards, Arduino boards also is cheaper than your top up. Okay, and then you have to fork out your own to fork out some of your money, because in previous semesters we did sponsor the student financially, but it didn't turn great. Okay, some of the parts didn't be returned, and then some of the project not being delivered properly, which is not which is not a good ROI from the school side. So this time we are deciding that you need to fork out your own money for this project. Okay, you don't see this as a burden, because you need to see other students at other faculties where they, especially the architecture, where most of their project there's no special money for the project, for the student to deliver the project. They have to work out on their own. Same goes when in the industry. Usually in industry, if you want what to do or start with a new project, usually you don't wait for somebody giving you money. You need to find out on your own. You need to solve it on your own. But in case of throughout this semester, somebody is willing to sponsor us, then you are going to be in luck lah. Okay, but I cannot promise you. But currently, myself and Dr. Izari were working in getting the sponsor from the school, and upon approval, then you're going to have a small assistant, but it's not going to be very big money.
Understood, doctor. Thank you.
Okay. Okay, other question? No. Okay. Okay. Now this is I'm going to talk about the design process in general. so that you can get a bigger picture of this subject. And in details on the theories of design process is going to be delivered by Dr. Izhari. Okay, so basically for engineering design process, okay, usually in general it comes out with this one. So if you're familiar with the control system layout, you already took control subject, right?
Yes.
Okay, then you shouldn't. You should not. You should have any problem with this layout. So basically, request for basically the engineering work comes with the request from client. Okay, request from client. Okay, and then you're going to do the process. Okay, can be anything, design, manufacturing, and then to produce the output. Okay, until you get what your client want, this process will keep on. Sorry. Until you get until you can deliver what your client want. So basically, this process will keep on repeating itself. Okay, this one we call as an iteration, design process iteration. So this process is actually a general design process. Whenever you want to design something, doesn't matter like if it is related to engineering work or non-engineering work. Okay, let's say that you want to make something for, let's say you want to sell something, let's say what, iced tea. Okay, you may want to make an iced tea to sell at Pasar Malam. So basically you're going to make a good iced tea to sell. If not, people will not buy your iced tea. So in order for you to sell the best taste of iced tea, so you're going to make that iced tea repeatedly, okay, over and over again until you get the one that being favored the most by the buyer at the Pasar Malam. Okay, same thing for engineering. It's just that this process, okay, it's just a general process where we're going to take a look into details of a method that being used by the industry in designing or producing a product. Okay, any question about this one? About this general design process? No?
No, doctor.
No question, Doctor.
So if I'm talking too fast and you can't hear my voice clearly, so you can ask me to repeat what I'm saying. Okay. Okay, now for this process, so basically you're looking at a simplified engineering design process, where you have a request from a client, and then this request will go through several processes, and then okay, this is a big one process, which the details are going to be I'm going to share after this. And then your request, the client request, going to go through the process. You're going to think, to fabricate, and then if not, occurring or the output is not the same as the client's request, so you're going to repeat the process repeatedly. Okay, but this one you need to do it very careful, because if you don't design it, what we call as design first time right. So basically, you're going to cost a lot of time and a lot of money wasted. Okay, usually we try to minimize the iteration process over here. Okay, usually engineers at company will, even though that they're going to have several design iteration, they're going to minimize the cost. Okay, by not actually doing it, but by doing it virtually. Okay, so that we're going to take a look. So that's why you learn about CAD, computer aided design, which is involving SolidWorks, and also some of you might be known the term of CAE or computer aided engineering. So the design being designed virtually. Once you confirm that they're going to fabricate it physically. So by doing this, you can save time and cost. Okay. So for this one, okay. So there is a lot. Okay. So I'm going to make this one. Okay. Okay, now the actual process that involved in engineering design is this one. So the first one is you're going to receive design design requirement. The first one, you're going to have a design requirement. And then you're going to come up with the conceptual design. And then you're going to have the preliminary. You're going to have preliminary design specification. And then once you have your design, okay, you're going to have you're going to proceed. This is one with the design. Okay, with design, which involve both the CAD, the CAE software. Okay, and then once you have this one, you're going to finalize your design. Okay, and then you're going to come up with your final design specification. Okay. So this is the workflow. Conceptual design. You're going to have your preliminary design, and then once you have this one as your initial design, you're going to use it to design your CAD and CAE, and then this one will evolve. At this stage, both of these two need to be optimized. Okay, once you have optimized, meaning that you can give the best with whatever you got, with whatever you have, and then you can come up with the you satisfy design or final design. Okay, meaning that the design will not change anymore. And once the design being being agreed, that going to be the final design, and then you're going to come up with the final design specification. Okay, this one involving drawing, then involve part numbers, okay, and etc. Okay, this is actually being sent with the to the production. Okay, for mass production. And your job as an engineer is just up to this process. For the mass production, usually the industrial engineer or the plant engineer that going to arrange this mass production for the mass produce of the product. And in this subject, okay, if I say that for this subject, okay, and for AD1, you're going to learn up to this one. Okay, for the outcome for The outcome for this subject only up to this one. Oh, sorry, not to, okay, up to only to this one. Only design. Okay, AD1. For AD2, will involve designing or continuing your project up to the optimized design that you can fabricate. Okay, this is design 2. Okay. Okay, understand so far?
Yes, Doctor. But
Understand, Doctor?
I have one question, just a
Okay.
trivial one. You said that for the final mass production part is up to the industrial engineer and
Okay.
such. And so, right. So, maybe in the future where we design the product and then give it the design to the industrial engineer, are we empowered to verify the product itself so that it is up to the final design specification?
What again?
Are we in power, like kita ni ada hak ke untuk macam verify the final design, the final product so that it met the final design specification?
Okay, usually when it comes from design specification or design, those who can say that this product is good is not your job. It's usually the project engineer and the CTO, Chief Technical Officer. They're going to approve that design is okay. Okay, and because in company, if you're working in an engineering-based company, as the job as engineer is just to design up to satisfaction of your top management. Okay, because it's the money, the company's money. Okay, but it's your job to what to justify your design to them until they're really satisfied with what that you are doing, or you are producing something that already being optimized. There's nothing more that you can do based on the budget, because you see, when you go out and work someday, let's say that the company only allocate you with let's say that 1 million ringgit, okay, to produce a new car model, okay, which is impossible. You cannot produce one new car model with 1 million ringgit. Okay, usually you need more. So let's say that the company still insist you to produce a car with 1 million ringgit, and then you say that I can, but with 1 million ringgit I can only produce a buggy only, not an actual car on the road. Okay, that's it. Okay, so you need to optimize with what you got. Okay, so usually this one throughout the subject you need to learn about this one. As an engineer, you need to do this one: time, cost. Okay, time and cost. You need to manage these things. Okay, usually if you have more time, not more cost. It's usually fun. Okay. Okay, usually if you have a lot of time and you have a lot of money, usually you're going to have, let's say, the A1 product. Okay, meaning that you being allocate 2 years to deliver the project with unlimited funding to spend to develop your work. So basically, when you have unlimited funding to carry out the project, usually you're going to hire more engineers, you're going to buy more software, okay, and then you're going to appoint more subcontractors to do the job for you. Okay, because when it comes to what we call as giving or subcon this project to others expert, and then you're going to have a great product. Because currently in real life, for a big company, they don't really do everything under one roof. Usually they're going to design when it comes to fabrications, because they have money. They're going to pass the project, create as a sub project and give it to other companies, small company, to deliver it, and then in the end they're going to integrate it back. Okay, that is the concept of for the vehicle manufacturers like Proton. Any car manufacturer in the world been doing like that. it's nothing to say that they are having an R&D department, they are designing from scratch, and they are fabricating on their own. No, usually they have money to make things faster. Usually they're going to sub the project to someone else. Okay, but okay, let's say this one you have usually if you have time, and then plus you have low fund. Okay, usually your product is not A1 product anymore. Okay, it's not the good product. Okay, and then okay for this one, I cannot move this one. Okay, and then if you have time, if you don't have time, and then you don't have fun, and then you're going to be worse product. Okay. Okay, this is some of the scenarios in project management, because throughout time as an engineer you're going to encounter this kind of scenario. But for the big company like Proton, like Volvo, they have this kind of situation. Okay? They have time to deliver the project. Usually the project being delivered within 2 years time with a lot of engineers. Some of it are having thousands of engineers. Okay, so that's why you can see when it comes to the manufacturing or making a new car model, usually it's not a one-man job. It involves teamwork. Okay, it involves teamwork and proper management. Okay, but for this one, it's impossible for a company which don't have fund to make a new product unless if you have this one involving the consumer electronic products like a simple LED torchlight, and then that one can. But for bigger product with high-end product with a good looking product, good quality one, you cannot achieve that with this one. Okay. But for this one, of course this is the worst case. You don't have time to do it. You have big ambitions to do it, your high-end product, and yet you don't have money, and then you're still making it, and then it's just going to be a worse product. It's just going to be a level of maybe unfunctional proof of concept. Okay, this one, okay, and you're possibly like this. Okay. Your situation can be like this, okay? Okay. So your situation, it can be this and this one, depending on depending on you. You as a student, you don't really going to have a good fund. Okay, you're not going to have a lot of fun to deliver your project, but you have to. But this one time is representing your commitment. Okay, even though that you still have time and you do have low money, you're still going to produce a product. It's still working, but it's not going to be as good as if you have this kind of scenario. A lot of time and a lot of funding. Okay, it's just that it's still going to be acceptable for this subject because you're still learning. Okay, you need to go through to this one. So I'm just telling you the truth about this subject. So some of the design so far that I've seen in your seniors, even though that me and Dr. Izari, we are sponsoring the student in delivering the project. The students is a bit reluctant in forking out their own money. So as you can see, the type of the project is just up to the 3D printed material, which is not good lah. This is your final year. You're supposed to produce something which is solid, which is the material involved should be metal. Okay, because metal is quite a steady and robust product. Some of your seniors project is actually a good design, but when it comes to the actual fabrication, it's not really happening as what being designed. Okay, because of this one. Okay, you need to sacrifice some time to get an A for this subject. Okay, any question?
I have a question, sir.
Okay.
This is just a curiosity question, actually. You mentioned that a car need more than 1 million to design and to from scratch.
Yeah.
So what is the typical budget for designing a car from scratch for companies actually?
Well, when it involved from the design up to the uh, fabrication or plant or what mass produced, usually they're going to need at least 200 million ringgit.
Oh, okay.
Okay, it's a lot. Yeah? Because most of the usually when it comes to the manufacturing, most of the cost going to be put in the tooling. Okay, the tooling, the die for the press. Okay,
Okay,
the
I see,
more
I see.
for the price for the metal sheet. Okay, and then not to name the HR is actually the constant overhead, and then usually for the software they just going usually they're going to spend about 1 million. 2 million is the most, like Proton, the Proton budget for the software for the CAD and CAE is just 2 million a year, and then the rest is being overhead cost of the engineers. But the cost for the tooling to fabricate each components or the sheet, the panel of the car, it depend on the design itself. If they have a complicated design, and then the cost for the die, the press die, going to increase. So that one going to affect the overall cost or that the Proton need to invest in the project.
Okay, I see, I see.
Okay. So any other question? Okay. Now this is your output or things that you need to go through in AD1 and AD2. Okay. For AD1, most of it you're going to learn about the okay. For AD1, you're going to learn about this conceptual design. You already take it in the during the you have the earlier subject involving the conceptual design, right? What does it call this subject? In concept design, what is it? Engineering design, right? Uh, Apa ni?
Industrial design.
I don't know, something that you learn only to design the concept, just to design the concept of engineering design. Tahun 1 ke tahun 2 saya. Nama apa saya?
Engineering design macam ni.
Engineering design, right? Where you learn just how to make concept, sketching, right? Okay, that one. Okay, this is conceptual design. This one is you learn. But for this preliminary design specification, it need to be done based on what we call in house of quality. So this one you're going to learn with Dr. Izahari. Okay, so preliminary design specification. So you're going to be introduced in designing engineering design. Before you come, your conceptual design need to consider several elements such as safety, how it works, okay, where to get the parts, the regulations. Okay, you need to take a look at these elements. So we're going to do it systematically. Okay, previously in conceptual design, you did learn about the design matrix, right? Correct. Have you learned about design matrix in what engineering design previously? Hello? Matrix design?
Never heard of that before, sir.
Tak ada?
I don't
Tak,
recall.
matrix. Masa conceptual design awak tak belajar ke pasal design matrix? Yang tak silap saya subjek Dr. Effendi yang panel design aja. Dr. Effendi ke siapa dia?
Oh, component design sir.
Bukan component design, ni yang conceptual design. Yang where you have let's say that you have to make, let's say that to make contohlah, if you, for example, to make the can opener. So to make a can opener, you come out with several design concept. Let's say 3, and then out of these 3, there's a sub elements, and each design will have its own design element. So you need to select this design element, and then which one is the best, and then that one be done using a matrix. So have you learned that?
Design process, sir.
Design process lah. Yelah, concept design saya tanya. Betul tak?
Dia macam consider
Ada.
dari aesthetics tu.
Okay, so that one, that one you're going to apply same thing in this subject, but with additional of house of quality. Okay, because this house of quality, we need to decide earlier to avoid redesign, major redesign. Okay, sebab kalau contohnya, let's say that for example you are required to design, let's say can opener. Okay, you want to make for some reason that you give. Okay, this can opener need to be the handy the handy segment, the place where we hold the can opener, it need to be very long because you need to to apply more to allow a simple machine kind of operation to make it easy to pick up the can lid. Okay, so which is not true because sometimes even though that the concept is good, but it's not practical because nobody will have a long can opener to hold and carry everywhere, which is not good. And then they say that you already decided and you go to design something like that, and then top management is not happy with your design, so you need to redesign everything from back from the beginning, from scratch, which is not good. So that's why you need to design, you need to to determine the quality, the element of quality which affect your design, which is this one. Okay. Okay, this one, which is involving this one. Okay, this one, okay, you're going to go thoroughly about this one throughout this semester with Dr. Izahari. Okay, for my part, I'm going to prepare yourself with the CAD and CAE elements that require to be learned to deliver your project for your next semester, because I cannot start teaching you this CAD or CAE starting for next semester, because it's going to be very time consuming, and then you won't have time to fabricate and then do the analysis for the optimization next semester at the same time, because usually this one usually involving a lot of work. Okay, CAD SolidWorks motion, probably going to be involved the MATLAB Simulink, SolidWorks motion. Okay, for your this one for the purpose of optimizing your design. Okay, and then you need to remember for this one, I'm just this is CAD and CAE is just tools. There is no specific tools for CAD, and there is no specific tools for the CAE. Meaning that I'm not saying that the SolidWorks is the best software to be used to design your CAD model. Okay, and then I'm not saying that SolidWorks motion analysis is the best CAE tools to design your design, either you're going to fail or not. No, it's just tools for this semester, because in the future when you work up with the company, that company might have they're not using SolidWorks, might be using CATIA, might be using Pro-E, okay, any CAD model, and then might be using some of it. We might be using the Google Sketch, okay, to design their CAD model. And then for CAE, not necessarily they're going to use the SolidWorks motion analysis. Maybe they're not going to use the maybe they have ANSYS. Okay, to study the stress strain analysis of the part during how it behave, how the part behave during the dynamic loading. Okay, this one is not necessarily that what you learn in UTM with in this subject is the software. It's actually going to be the same software that you're going to use in the future when you work. No, it's just that for this subject, we're just going to provide you with the fundamentals, with the concept, with the understanding. So when you get the concept, when you grab the fundamental or the understanding on things that need to be done, so when it goes to actual work field, so you need to figure out on yourself by yourself using what you learned in UTM. Okay, let's say that for example, if you are using SolidWorks. So SolidWorks, let's say in UTM you learn SolidWorks, and when it comes to let's say you go and work with Photon use SolidWorks, they're using CATIA. So basically the same thing. You just need to familiarize yourself with CATIA. You have the fundamentals on how to use SolidWorks. Usually Same thing with CATIA, you need to produce solid part first and then do the assembly and then come out to the engineering drawing. Same thing with CATIA. It's just that you need to familiarize yourself with the button, how the button being arranged, where to find the buttons, where to find features, things like that. Okay, same thing with the CAE. They say that for this case, we're using SolidWorks motion and SolidWorks motion analysis to see the behavior of your design. In this case, you're going to design car, and then when you are running a car in a simulation, usually there's going to be load. Okay, this load usually in real life going to cause deflection to your car. Okay, and then this load is actually being categorized under the dynamic loading. So this thing you're going to analyze virtually. Okay, this is actually the part or the process that need to be done in actual industry. Okay. Okay. Any question about this one? Okay. Any question?
No.
No.
Okay. But and then for this one, wait, dia hilang. Alamak, tadi saya sepatutnya alamak dah terhilang lah pula. Okay. Okay, never mind. Okay. Okay, ada. Okay, and then for this one, for CAD, initially for 81, you're going to produce a report of your preliminary design specification plus your conceptual design for CAD and CAE. Okay, but if you can produce the CAD model and CAE as a preliminary result, then it's going to be good. Okay, and then for next semester, you're going to reuse the same design and you're going to optimize. Okay, for better performance because based on the CA result. Okay, for this one, okay, then for this, okay, and then in 81, 82, this is the tools that you're going to use, MATLAB Simulink. Ni betul saya klik. Okay, for this one, design CAD and CAD. Okay. For design process, for design purpose, okay. Okay, for design purpose for this one, okay, design CAD and CAE, you're going to learn about the first one is MATLAB Simulink. And then you're going to learn MATLAB Simulink plus Arduino. And then next you're going to learn about SolidWorks. You already know it, but I'm going to focus on SolidWorks motion analysis. Where we're going to take a look at the dynamic static. Static is a normal static loading, dynamic loading, and fatigue loading. Okay, this one for motion analysis, it involves multi-body simulation. Okay, for this one, Yeah, multi-body simulation is like you're going to model a CAD model into you're going to model your system into a CAD model, and then using that CAD model, you're going to simulate it as if it's like really happened in real world, and based on that motion, you're going to use the load that been created during your simulation and see the effects on your parts. Okay, so that's why you see in some engineering work, you see that some interesting color contour on the car when it's moving. Okay, this is actually the effect of the effect of dynamic loading on the car motion. Okay, uh, this kind of analysis that is just an introduction for you. It's not going to be as detailed as the one that they use in industry, but at least it's going to be a good exposure for you guys to know that these things are the things that need to be done when you are designing things in the future when you work with in the industry. Okay, for that purpose, I want you to have the MATLAB Simulink installed, and then I want you to have the Arduino support package for MATLAB to be installed, and then also I want you to have the SolidWorks Motion. For this one, I'm using okay, I already checked. You can use any version of SolidWorks, but please make sure you have SolidWorks Motion Analysis installed in your SolidWorks Motion. For me, myself, I'm going to use SolidWorks version 2016. Okay, for the tutorial. Okay, and then just that the con is that if you have your file to share with me, I cannot open it because for those using 2017 and above, 2016 version cannot open it. Usually, the newest version can open the older file, but the older version cannot open newer files from the newer version. Okay, but for Simulink, I'm using for Simulink, this one I'm using 2000.
Is it 2020A?
Pardon?
2020A.
I'm using 2020. No, usually I'm using 2020A. Itu saya cakap 2020A.
If I'm not mistaken.
Okay,
Yes.
2020A. This one, if you want to use older version of Simulink, then it's okay. But not 2020B or 2021A, I cannot open it. Okay, for Arduino, make sure you install support package for Arduino. And then for SolidWorks, last time I told you to find the SolidWorks 2013. Now it's okay. Never mind, I already checked because the layout for different version is is actually the same for motion analysis. So there should be no problem if you want to use a different version of SolidWorks. Okay. Okay. Any questions so far? So this one MATLAB Simulink. Okay. Let's go through to your design in general. So basically, this is actually the okay. I already share you the overall view of engineering design process, and then I'm going into details what you're going to learn in AD1 and AD2. Okay, and then also with the software that being involved in for this subject, and then now I want to show you why are we using this subject, this software. As a part of the CAD and CAE software. Okay, so basically, okay, in design, so it involves CAD, okay, and also it involves CAE. Okay, for CAD, you're going to use SolidWorks. Okay, and then okay. For CAE, it's going to involve MATLAB, Simulink, plus Arduino, and then it's going to involve SolidWorks Motion. Motion analysis. Okay. Okay, this is how we group your software. The SolidWorks actually is involved the CAD work that you need to do, and then for CAE you're going to use MATLAB Simulink and plus Arduino. This one is because some of your subsystem going to be involving a control system, and then you need to analyze that control system using MATLAB Simulink first before you are applying into or you are going to flash it into Arduino board. So we're going to analyze that the behavior of control system using MATLAB Simulink first. Okay, and then you're using SolidWorks motion analysis. Okay, to study the structure integrity of your electric vehicle. Okay. This is the purpose of this software, or the purpose of your learning, especially this one, SolidWorks Motion and MATLAB Simulink Arduino. How, where we're going to use it in your project, specifically for your subject. Okay, this is only for this subject. When you in real life, when you start working, not necessarily that you're going to use this one. Okay, but usually the process or the process or things that need to be done is still the same. Okay, it's just that usually you're going to continue with what you have, what your company willing to buy, the software, the CAD software, the CAE software. So it depends on them. So if your company is preferring the Pro E or the CATIA, and then you need to learn how to use CATIA. And then for CAE, if your company is actually having ANSYS software to study the stress strain analysis, and then you need to learn how to use the software. So, but the concept, the process are still the same. Okay, which is this one. So I still this one. Tadi setting yang mana? Sekejap, sorry. Okay, ini sekali lagi. So design. So basically in design, you're going to use CAD, and then you're going to use CAE. For this subject, the CAD involved is SolidWorks, and then the CAE software involved is MATLAB Simulink, and SolidWorks motion analysis. Okay. Okay. Now let's take a look at your project. Your project is basically you need to design a portable electric vehicle, right?
Yes, Doctor.
Okay. I'm going to simplify this your portable electric vehicle, because I believe the product design requirement for that electric vehicle is not being being set by us yet. So basically, this is your car. Sorry. Okay, this is 3D view. Never mind. Okay, this is your car. So basically, your car going to consist of the powertrain, and monitoring, and then it involves the steering system, right? And then also it's going to involve the ride and handling. And then it's going to involve powertrain, steering system, ride and handling,
Structure and safety.
okay, structure and safety. Structure and safety. Then lastly, another group is supposed to be working on what? We have 5 groups.
System integration.
Okay, system integration and homologation, right? Okay, based on this subsystem, okay, this one for the group that been doing this one, you need to be focusing more on the this group should be focusing more on the MATLAB Simulink Arduino. Okay, for system integration, this one I'm talking about the software. I'm not talking because I'm not talking about the what I'm not talking on type of job that you need to do more. No, I'm talking about the tools that you're going to be used frequently. Okay, but of course, all of you still need to learn about Simulink, SolidWorks Motion, and Arduino. So this one, system integration, going to be used more on the SolidWorks. Okay, just SolidWorks, because it involves the system integration. Because this group going to take the parts or the component that be made by other group and to assemble it in the overall portable car, plus with the what the standard parts or components such as the lighting, such as the horn, such as the side mirrors. Okay, that one of that kind of part that need to be integrated. Okay, and then you also need to consider the wiring. Okay, the wiring and then the packaging layout. So that thing need to be done in SolidWorks. Okay, so this group going to be working more on in using the SolidWorks. Okay. Okay, for this one, for this part or for this group, okay, this group going to be focusing more on the CAE SolidWorks motion analysis, and plus because more on the FEA work, plus for the FEA work, finite element analysis. Okay, this one for this structure plus okay, this one, but still you need SolidWorks lah. Okay, SolidWorks. Okay, for this one, for this group, they're going to involve being using more analysis on MATLAB Simulink. Okay, MATLAB Simulink because this one is going to involve control. So you're going based on design, the design of the chassis, what dimension, because chassis dimension and then the suspension tuning. You're going to do that by using by developing a simulation model and run it in MATLAB Simulink, and then also run it in the simulation of your car in using SolidWorks Motion. Okay, MATLAB Simulink and also the SolidWorks Motion. Steering system, you need same thing. So steering system, and this one I need to okay, this is another one, steering and braking system. Okay, and braking system. So this one also is going to be done in the MATLAB Simulink. And then SolidWorks Motion. Okay, and then special needs is that especially for this one. Okay, so for system integration, you also need to come up with the integration of monitoring system, because this one powertrain monitoring, they have its own monitoring system, but this one only for the battery consumption. Okay, but for the condition of the project, let's say that the kinematic properties of it, meaning how fast your car is going, and the velocity of it, and okay, how far it travel, you need to monitor using telemetry system. So this one you are responsible to deliver it in the second semester. So but at the beginning, you need to integrate the telemetry. Okay, for telemetry, so this one is involving the MATLAB Simulink Arduino. Okay. 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 So this one, I'm just highlighting the software that you're going to use most. You're going to use most for your work. Okay, it's not showing that what kind of work that need to be done. No, this one is just the software, the tools that you're going to use for your work of in your team. Okay, any question?
No, doctor.
Okay, clear. So please make sure please keep this one record because I'm not saving any slide of it because I'm not sure. I'm using a new whiteboard and I cannot find how to save this slide. Okay, okay, never mind. Okay, any question? No. Okay. If no question, we're going to take a break about 10 minutes. No, 10 minutes. So I'm going to come back at 3:40, and then I'm going to share with you on the how to use the MATLAB Simulink and why we are using it. Okay. So see you in another 10 minutes. 10 minutes. So we're having 10 minutes break.
All right.
Okay, Doctor.
Okay.
Okay, doctor.
Okay, can I continue now?
Yes, Doctor.
Okay. Okay, Muaz. Okay, sambung record lah. Okay. Okay, now we're going to continue with the introduction on MATLAB Simulink. So, any questions on things that I already showed previously on the general overview of what you're going to learn and what you're going to do in this subject? Any question? Ada soalan?
Tak ada soalan, Doktor.
Okay, good. Now, okay, we're going to take a look at the MATLAB Simulink. Okay, so basically MATLAB Simulink is more like I believe in this class for this 81, I think most of it are those who already took Wiki Dynamics with me last semester, and those students actually learn about MATLAB Simulink, so there's going to be a great advantage. And then for this subject, for auto design, I'm going to reteach the MATLAB Simulink. So hopefully those who already learned about MATLAB Simulink will get practice over it again. And then please make sure for those who didn't really catch up the MATLAB Simulink class in VD subject with me. So please pay good attention, because I'm going to repeat again. Plus with more advanced level in using the MATLAB Simulink. Okay, and then for those who are about to learn this software, so please pay attention, because you're also going to use this software in delivering your project. Okay, so basically MATLAB Simulink, because if I'm not mistaken, all of you already took the programming subject, right, in the first year, correct?
Yes, we did, sir.
Can you please tell me what did you learn during in that subject for programming?
Basically, we just learn about the C language programming and the MATLAB.
Okay, so
The
basically,
Simulink can be quite new actually.
okay, so basically, programming with MATLAB Simulink is the same thing. It just comes with a bit of twist, because in C and MATLAB coding that you learn is what we call as tag-based coding. Okay, if let's say that for this one is data flow programming, what we call as the data flow programming. Okay, and then IE for C, C++, or MATLAB coding. So this one we call what we call as a tag-based programming. Okay, and then usually when it comes to coding, we use most of the text, most of the coding being done in text-based programming. But MATLAB Simulink, in my opinion, I think I'm not sure for the rest of you who already learned about Simulink. So MATLAB Simulink provide with the data flow programming.
Saya ada nak share screen ke?
Awak nampak tak sharing screen sekarang?
Tak.
Tak ada.
Kenapa tak cakap, Muaz?
Oh.
Saya ni salah ni.
Aduh,
Kita orang memang tak tahu pun doktor tengah share.
Okay.
Okey, nampak doktor.
Okay, nampak Okay, nampak?
Nampak doktor.
Okay, now saya repeat semula. So MATLAB Simulink ni is actually falls under the what we call the data flow programming. So other type of programming that you use to learn or see or figure out to learn about it is C, C++, and then MATLAB coding. So C, C++, and MATLAB coding is actually what we call as a text-based programming, where you need to type certain text or command to build up software. Okay, but for MATLAB Simulink, it's actually it's also a program, but it's being done in using data flow programming and then using a visual blocks. Okay, visual blocks. So let's say that you have one algorithm or one mathematical functions. If it's in C or C++ or in MATLAB coding, you need to type that code or you need to type that mathematical functions in the text, right? But in MATLAB Simulink, no, you're going to rearrange or arrange a set of blocks that can be used to represent that mathematical function. Okay, and this is actually a bit faster and more efficient than C, C++, because it allows you to see the structure of your coding, which can be easy when you want to cross-check with the original mathematical functions. And then also MATLAB Simulink will provide the easy troubleshoot. Okay, let's say that you develop for example in C, C++ or MATLAB, whenever you do the coding in the wrong way, it's just going to tell you that something is wrong with code. But in MATLAB Simulink, if you develop or do the block arrangement in the wrong way to represent a mathematical function, then it's going to tell you specifically what's wrong with it. Either you are actually arranging the block in the wrong way, or you haven't defined something in your block. Okay, so this is the main advantage for MATLAB Simulink, which I prefer a lot. Okay, but also this one also comes with a con, because for MATLAB Simulink and you can do complex calculation software MATLAB Simulink, but it just going to have a huge block arrangement, which can be haywire or looks complicated, and then can cause you it's not good. The arrangement is not as good as the C++, because in C++ you can have up to millions of lines of code, but not in Simulink. You have a limitation. It's not limitation of that Simulink cannot do it. Simulink can do it. It's just that it's going to looks very complicated in the window. Okay, I'm going to show you after this in MATLAB Simulink. Okay, usually the process involved in MATLAB Simulink. Okay, this is the process involved. So basically in Simulink, we're just going to have input. Okay, and then we're going to do some process. Either we're going to process the inputs, either involve the mathematical operation or just a command to actuate something. This one we're going to take a look in the MATLAB Simulink Arduino, and then also we're going to have, and then once we process this input, we're going to have output. Okay, and we're going to have output. Okay. Okay, this is the this is the input, then this is the output, this is the process, and then this is the output. Okay, for the input, okay, your input in your Simulink Simulink coding or Simulink program or MATLAB Simulink program can be based in the form of constant. It can be experiment. It can be in the form of wave, and it can be in form of data. Okay. And then in process, your process usually going to involve math operations, uh, decision, event-based decision. Okay, and then also can involve artificial intelligence or AI. Okay, and then once we have the data being input and then it being processed, and then we can see the response of our system in the form of graph. Okay, form of a graph, and then this graph can be in form of a time domain, or second one is in form of frequency domain. And we're going to focus more on the time domain, because frequency domain involving data conversion, which cannot be done during the simulation. We need to get the data first, and then we're going to convert into frequency domain. And then this one is very tedious. Never mind, if I have time, we're going to take a look at it. And then second one, the output can be also in form of value display. Okay, in the form of value display. So this is the rough general concept in using MATLAB Simulink. And then for this one, okay, this is the category. So we're going to take a look at the one. Okay, can you see my slide right now?
Yes, we can.
Yes.
You see my MATLAB, right?
Yes. Yes.
Okay. Sorry. Okay. So basically, I believe when you learn in your programming subject back in first year, you learn about on how to create the MATLAB code by creating new script, right? For MATLAB Simulink, to start a new MATLAB Simulink, you need to click this Simulink button, this one over here. Okay. Once you click it, usually it's going to give you several options on type of files that you would like to open, and usually we're just going to create a new blank model, which is this one. This is just an empty model. I just need to wait. Hopefully it's not taking too long.
Doctor,
Yeah.
for using the software as you previously mentioned, like MATLAB and Simulink that you are currently presenting, and then SolidWorks, do you have any like recommendation on the specs of the laptop or anything?
Okay. For spec of laptop, I would prefer the gaming spec, of course.
The fastest and the
Yeah, the fastest one, and as fast as possible you can get. But yeah, if you can get it, just you have to bear with the processing time of the RAM. Okay, you have to bear it. If not, you try to get the best one is always a gaming spec. Okay.
And how many RAM do you recommend from your experience?
For gaming spec, the best one, the cheapest one is actually by MSI. I think less than 5K. I think between 5,000 to 4,000 to 5,000. 30, I think 16 gig RAM and 4 gig or 3 gig for the GPU. For the GPU. Okay. The ones be good enough. Okay, so now can you see my Simulink?
Yes.
Yeah, okay, this is the Simulink interface where Um, uh, okay, this is the empty space for Simulink where you're going to do the block arrangement for Simulink, and the blocks that can be used to represent your mathematical functions or your coding. Usually, you can get it from the library browser. So, if you install Simulink, usually it will be installed along with other functions, but the rest we're just going to ignore it first because most of it we're going to use it. And the block, most of the block will be what group under the Simulink category, which is this one. Okay, the most okay. Okay, the most block that we're going to use is belong to this one under the sources, and sync, and then math operations. Okay, this is the most what subcategory that we're going to use each block. Okay, yeah. Yeah. Okay, this is the input. Where input we have a lot of input that we can use. They can be constant and it can be in form of waves. This one, and also we can be use experimental data, which is this one, this block. We're going to take a look at this, and then for the math operation, we learn this one. So these are the math operations. So plus minus, multiplication, power, square root. So everything can be found in under this category. Okay, the rest which I'm just going to show you an example when there is a need of it. Okay, and then another one that we're going to learn about that very interesting for you to learn is how to use the dashboard element block. Because by using this one, you can create your own user interface within the MATLAB Simulink. Okay, you can create your own graphical user interface, which is very interesting. Okay. 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 This is the back to the concept or fundamental of how to use MATLAB Simulink. Basically, your Simulink model should consist of the inputs. The inputs need to be processed by certain operations, math operation, or even basic decision. And then it need to be what we need to channel out the output in terms either can be you going to monitor in the form of graph or it just going to be in the form of only a value. Okay. Okay. Now okay. Now for example. Okay. Let's say that we have one mathematical equation, a linear mathematical equation, y equal to let's say 3x plus 5. So this one is just a simple y equal to mx plus c. Okay. So first thing that you need to remember. The way that Simulink works is that the data flow from left to right. So meaning that when the data flow from left to the right, meaning that your input need to start entering the flow, the structure need to start working from the left to the right. But in this equation, we have the y, which is the output. We found it first. Okay, so which is not when you want to start with the Simulink, you need to rearrange this mathematical function first. Just need to make sure that you need to arrange your block, which represent the restructure equation, which is instead of y equal to 3x plus 5, you need to make your block 3x plus 5 equal to y. Whereas this is your, and this is going to be your input. Okay, and then this one is going to be your constant, your math operation. Okay, and then this one going to be your output. Okay, so for example, this one, if you want to make this equation, so this is 3x. So basically in MATLAB Simulink, there's one block for multiplication, this one. So we're going to have a constant of x, and we're going to have a constant of 3, which is fixed, and then we're going to add it with 5. So we have the addition block, so plus 5. Okay, since that this is only involving constant, we're just going to see the answer or the result by using display block. Okay, this one is a display block. Okay, so I'm going to show you you need to remember. So this is very important whenever you want to, if you have a set of mathematical equation and you want to model in MATLAB Simulink, you need to make sure that you need to rearrange the placement of the equation with the inputs need to be located at the left side of your model, and your output going to be at the right side of your model. Okay, but for the output, later on we're going to take a look that any output is actually can be tapped or being tapped anywhere in the simulation. But the ones later we're going to take a look at it. But for the moment, at the beginning, so any equation you need to rearrange your mathematical equation at the left side first, followed by the output, which is at the right hand side. Okay, now for this one, okay, the equation is 3x plus 5. Okay, sources. So we have sources. We have sink. Sources is for the input. The sink is for the output, and then this is the math operation. And then another one. Since that this is the most common block, other than looking at the blocks under this category, you can also find this block under the commonly used blocks. Okay. So in this case, I'm going to use just to introduce you, I'm going to go through into the category for each block. For sources, so I'm going to take this constant. So this one is going to be x. X, then we're going to multiply under the math operation. Go to the product. Okay, product is the multiplication. And then we're going to add up this one with a 5. So you can resize, actually you can resize the block. Then paste at 5. So this is your output, which is y. And then let's say that you want to see the result or the answer for this block arrangement, which represent the math function. Okay, just take the display under the sink category. Just take out the display. Okay, and then this is the stop time, which is the simulation time. So for the moment, we're going to let it run at a default value, which is 10 seconds. Okay, and then to run this one, okay, first we haven't defined anything yet, or we haven't defined the value for x. So we can do that by entering the x value in the main interface, which is x. Let's say that x equal to 2. So how do you know that the values already being keyed in into the MATLAB? So you can take a look at the workspace area, which is this one, x equal to 2. So this is the parameter's name, which is x, and then this is the value for the x. And once you did that, okay, and then you just to run it, you just click the play button. 511. The answer should. So this is the answer of 11. Okay, this is if you have if you're using constant value, it's advisable for you to use display because you're just going to get one or a single answer. Okay, but okay, there's difference between using the display block and the scope. Okay, the scope is actually going to display your answer in time domain, meaning that throughout the time the simulation being performed or being carried out. Let's say that we are running this the calculation for 10 seconds. For you're going to have a straight line of 11 value throughout from 0 to 10 seconds. Okay, so that's the difference between using this display block and this scope block. So I'm going to run again. Oh, dia tak bagi dah. Yep. Dia tak keluar line. Okay, for all the version, when you run, you are running a constant, constant value. Usually, you're going to get a straight line of at the value of 11 from the starting of the simulation time till the end of the simulation. But in this case, this version is I think just installed 2020. It just stopped at this value, so showing that this result preferably being viewed using display block, not the scope. Okay, but to see how the scope behaves, okay, now we're going to change this one constant input by using the wave input, which is in this case we're going to use let's say the sine wave. Okay, double click the sine wave. So the amplitude for the sine wave is just 1. So meaning based on this function, so the sine wave, its amplitude going to amplify 3 times, and then being offset by 5 units. Okay, and then we're going to see the differences. Okay, this one is the Y line, and this one is actually the input. Input. We're going to rerun. Sorry, better change this one to 2. Okay. So if you take a look at this one, this is not displaying anymore 11 value, because right now this block is just showing the last value that being calculated in Simulink. Okay, if you want to see the actual result for this function when the sine wave input being used, so just click the scope. There you see. There you go. So basically, the blue line is actually the original input, and then this yellow line representing the input that already gone through the process, which is the multiplication of 3 and then offset of 5 unit, which is this one. Okay, and then this is the result. And then if you are doing this one using the coding C++, C language coding, so basically you need to type everything, okay, up to this one, but not for in Simulink, where you just need to know the block and then just do the block arrangement that can represent that mathematical equation. Okay, any question?
Doctor, let's say we've completed our Simulink punya module, nanti kita nak deploy in the project pakai apa?
No. Right now I'm just showing you this the software side of Simulink. Okay, yang do you mean deploy in compile or deploy dalam Arduino?
Oh, nanti kita pakai Arduino, nanti kita compile.
Okay, yang Arduino tu lain. Yang sekarang ni okay, for compiling, okay, yang bila saya tekan play tu maksudnya dia equivalent dengan compiler dalam C language.
Ya.
Itu compile. Tapi kalau when for deploying, that one we have steps to set the Arduino block in our Simulink. We can actually flash this algorithm into Arduino board, and then see the result when and then tune the result while we are running inside the Arduino board. So that one later on. So just we focus on mastering this MATLAB Simulink first.
Okay, thank you, Doctor.
Okay, any other question? Okay, semua dah ada, everybody already install your own copy of MATLAB Simulink?
Yes.
Okay, good So now, okay, I'm going to go for second example. Example 2. So we're going to use the same math function. This one I'm going to use as an easy one. Y equal to X kuasa 3, X kuasa 2 campur 100. Okay, let's say that I'm going to use this one with MATLAB Simulink. So basically we have several options where this is our input of X. Okay, we have yep.
Oh, sorry.
You consider dulu lah, X kuasa 2 campur 5X campur dengan 10. So basically in the form of a Simulink model, like I say, you need to rearrange. So at the beginning, if you cannot imagine this equation, you need to write it down. As later on, once you get it, how the arrangement need to be done, you can just do it, the equation rearrangement in your mind lah. So now I'm going to put it over back like this. F equal to 10 equal to Y. So basically this is your X. So you're going to go to power of 2 because this is a special function for power of 2 in Simulink, and then you get this one, okay, but you need to have the 5X. So we have 3 terms that going to be added up. So in the add block, we're going to double click the add block function and add another plus sign in the block. Then for the second term, we have 5x. We're going to multiply with 5. Okay, this is 5. So for this one, we can reuse the input of our input by tapping the signal line. Okay, simple like that. So this one is going to be 5x. We're going to go over here, and then for the third constant, which is for the 10. Okay, this is our block, so our display. Okay. Now, what I want you to do is that open your MATLAB Simulink and try to do this one in your Simulink. Okay, I'm going to come back. I'm going to call randomly within 15 minutes. Okay, after 15 minutes, I'm going to call you back after 15 minutes to see what have you done. And then meanwhile, within these 15 minutes, if you have problems, okay, you can ask me. Okay, understand?
Alright.
Okay, do this one first. We're going to do it slowly at a slow pace at the beginning. Don't worry.
Doktor nak tengok balik the equation.
So 15 minutes. Okay, I will come back at 4. Sekejap ni 4:30. At 4:30.
Doktor,
Ya.
untuk blok X tu, apa nama blok dia?
Constant.
Constant. Oh, okay.
Constant, then awak double click, then awak tukarlah dia punya ni. Tapi value-nya awak kena masukkan dalam main interface MATLAB.
Okay. Alright.
Okay.
Just nak declare value untuk constant je kan? X equals to
Ya, cuma type X equal to any value lah dia yang awak nak pakai.
alright, thank you.
Sir, U square tu
Okay. U square.
okay.
U square awak boleh tengok dalam math operation under this one, math function. Awak tarik keluar, awak double click lah. Then dia ada power. Magnitude of 2.
Okay, sir.
Okay, yang lain-lain tu awak boleh tengok lah. Okay, ini magnitude of 2 lah. Okay. Okay, done? Okay. Amir Arif. Amir Arif. Amir Arif ada tak?
Hello, hello
Ah,
doktor.
awak tolong share awak punya screen jap. Yang Simulink saya nak tengok. Dah okey cuba run. Value dia, value X awak pakai berapa? Dua okey lah betul tu. Okay. So next Afiq Abdul. Afiq Abdul.
Doktor, I'm sorry doktor.
Ha?
My lab got crash.
Ya ke? Buka awak punya MATLAB, saya nak tengok awak buka MATLAB ke tak? Nak tengok awak ada MATLAB ke tak ni? Mama Yasir terus keluar. Ni siapa yang keluar ni?
Aduh, ya sih.
Okay doktor, tadi kan saya ada crash kan doktor kan. Lepas tu I try to fix it but there's something wrong, then I uninstall.
Bola ya ke ni? Ke
Ya,
memang
betul.
tak install? Tak install, cakap lah tak install.
Betul doktor, serius.
Betul?
Betul.
Tak apa, next time saya cari awak dulu, saya tunjuk. Untuk tunjuk kat saya.
Okay, doktor. I try to install back, insyaAllah.
Try to install, ke memang baru nak install? Tak install lagi, dah install ke tak install ni awak ni? Cakap betul?
Install doktor. Okay,
Betul?
So lepas tu saya uninstall balik sebab I try to fix it but I can't find the exact location of my file actually.
Okay, sekarang ni awak tunjuk kat saya, awak punya installer MATLAB share kat screen. Saya nak tengok awak ada installer tak?
Installer wait.
Jangan awak kata laptop awak crash pula. Awak tunjuk kat saya, awak ada tak? Ada tak ada? Tak ada, cakap lah tak ada. Ada tak ada ni?
Ya tak ada doktor.
Cakap lah tak ada, kan senang ni. Saya dah tanya awak kata Simulink crash. Ini dah betul-betul country baru awak mengaku kata tak ada. Kan senang kalau cakap tak ada. Yang lain-lain pun for the rest, so please make sure bila saya minta awak buat lah. Jangan cakap kata tak ada crash lah apalah, sebab saya tahu trik student bila kelas online ni. Okay, so please make sure kalau tak ada, tak ada. Kalau awak buatlah. Kalau tak boleh buat, awak bagi tahu saya. Okay, sebab kalau awak buat macam ni, awak and then bila projek pasal when it comes to project delivery, so when you cannot make it, you're going to blame me. Itu tak kena lah tu. Okay, ni kita dah jumpa seorang ni, siapa? Afiq. Okay Afiq, next time saya nak tengok awak ada. Okay, next siapa? Randomly. So ini siapa ni? Lita ni, siapa ni?
Yes, doctor.
Okay, please show your screen. I want to see your Simulink work.
Okay, doctor. Because I using the phone and then I open the camera for where?
Okay.
Oh, Lim.
Sir, like this, but haven't finished on the way.
Okay, aku buat finish lah. Okay, next. So who is the international student? Saya nak tahu juga international student ni siapa. Ke dah keluar awal lah. So who is the, okay, so can you, Imam Zaid, so can you please share your screen? I want to see your work. Okay, so dah jadi lah, dah okay. So your thing, is it working?
So that's okay.
So, okay. Okay, next. Ni Asyik Kamal Aziz, dia dah expert dah ni. Okay, Hakim Rafi. So Hakim Rafi,
Ada MATLAB lagi tengah download saya.
tak ada lagi. Okay.
Sedang download.
Tengah download. Kenapa susah payah download?
Saya silap download yang 2021 punya
Awak dalam camp ke dekat rumah?
kat rumah.
Kat rumah, okay. Ni Fana ni siapa ni? Fana?
Saya.
Okay, tunjuk example awak.
Oh, saya tak siap lagi tapi kejap saya tunjuk. Macam mana nak share? Nampak tak? Hello?
Ni tak tahu buat ke, baru tengah buat ke, tak siap ke macam ni?
Tak, tadi mula saya macam buka kan. Saya macam, macam mana nak tarik? Saya tak reti nak tarik benda ni. So saya macam tanya kawan saya.
Boleh buat tak ni?
Boleh. Dah boleh.
Kalau tak ada, my intention is that if you cannot do it, just tell me, okay? Kalau macam the rest tu, kalau tak tahu buat, janganlah kata apa, tak ada, tapi bila saya check tak ada, memang saya marah lah. So ini expect lah. So this subject I'm going to treat you as an adult lah. If you make something which is not appropriate, then I'm going to straight ahead school lah. So because I expect this thing, because back in industry, usually if you're not doing proper job, even though your boss is actually a big guy, with highly educated, you're still going to get scolded. Okay. Okay. So any question? So yang lain tu just save by the bell lah. So any question before we're going to end today's session?
No.
Yang lain? Oh, sekejap awak ambil awak punya attendance dulu. Scan awak punya attendance. Saya lupa buat. Kat mana? Okay. Okay, so please scan your attendance now.
Sir, tolong screen. Tak nampak.
Okay, jap. Okay, please scan your attendance now. So for those who just run out, afraid of me checking the work, so nasib lah kan. So please scan your attendance now. Supposingly we have 27 seconds. Okay, tadi saya ada sampai 28, 29.
Doktor,
Yep.
any MATLAB before R2020A boleh pakai kan?
Can.
Okay.
Okay. If you want to let's say that you have intention to share your files with me in the future, then better use 2020A and below lah. Okay. Because 2021 I don't have any copy of 2021 version.
Okay.
Okay. Okay, anybody else? So for those, so far just 22 students that clock in, meaning another 5 is
Doktor, kejap doktor.
Hmm?
Kejap Saya belum scan lagi.
Okay, scan.
Okay, kejap.
So any other question?
Last question for the Simulink. So let's say kita tak optimizekan the blocks, as in like kita pakai lebih banyak block daripada apa yang patut. Will it like affect the performance masa
No, not really. It's just that when it comes that you're doing something wrong, when you want to do troubleshooting or of signals, because sometimes you might pull out the signal lines wrongly, and originally your signal layout is actually in haywire forms, then you're going to face some problem in identifying the source of the block signal line. Just it only lah. Okay.
Okay, thank you.
Okay, I'm going to deactivate the QR code for another 2 students. I think I'm not sure that these 2 persons is in class or what. Okay, so okay. So if you don't have any other questions, so see you next week. So next class is going to be with Dr. Izahari. Okay, during lecture class. Okay, bye. Assalamualaikum.
Thank you, sir.
Okay, thank you.
Thank you, doktor.
Thank you, Doctor.
Terima kasih, Doktor.
Thank you, doctors.